In this video, I'm going to solve the second question from chapter 11, rolling torque and angular momentum. Actually, this question 28 is related with angular momentum. Let's read the question. What is given in the question? A 3 kilogram particle-like object moves in a plane with a velocity component v of x, which is equal to 30 meter per second, and v of y, which is equal to 60 meter per second, as it passes through the point with xy coordinates of 3 comma minus 4 meter. So you have the particle and which its mass is mentioned here as 3 kilogram, and this particle has the velocity component which is v of x, which is equal to 30 meter per second, and v of y, which is equal to 60 meter per second. So if you want to write the vector equation for this velocity, therefore vector equation which is equal to 30 meter per second I cap plus 60 meter per second j cap. Clear? Because they mentioned the component, right? So that's what I just wrote this equation in terms of vector form, because this question is related with a vector, because angular momentum is a vector quantity, so we have to deal with a vector notation. Clear? And when it passes through these coordinates, what is the coordinates? They mentioned the coordinate value x comma y. What's the value of this x comma y? 3 comma minus 4. So if you want to write again the equation, the vector equation for this point, so we can just use the position vector r, which is equal to 3 I cap meter minus 4 j cap meter. Actually, this point will come here. So if you want to indicate this point in this graph, so I can use this arrow mark. So let's consider this is the position of this particle with respect to origin. Clear? Clear? So this is the value of 3 comma minus 4. Let's we take this is the position vector. So if you write the equation, vector equation for this point, or vector which is equal to 3 I cap minus 4 j cap, and its unit is meter. Clear? Okay. Now we are going to answer just then in unit vector notation what is its angular momentum related to origin, because we exactly connected this position vector with respect to origin. So first question, we are going to find the angular momentum of this particle related to origin. So we have to compare this 3 minus 4 meter, that means this coordinate, with the origin. Clear? So for that we have to use the rule. In theory we studied the rule for the angular momentum. So angular momentum formula is given by the equation angular momentum L vector, which is equal to R cross P, right? So this rule we studied. So if you just write, we can write R cross M multiplied by V, right? If I took the mass, because mass is a scalar, so you'll get R cross V, right? So now what I'm going to do, if you want to find the angular momentum for the first part, first of all, I'm going to find the cross product of R cross V. And after I found the answer for this R cross V, I'm going to multiply with the mass, because mass is a scalar, right? So first of all, I'm going to find this R cross V, because in chapter 3, we studied the method of IJK, right? So here, what are the equations we have for R and V? For R vector, we have the equation, vector equation, 3 meter I cap minus 4 meter j cap. And what is our vector equation? Our vector equation v of x is 30 meter per second I cap plus 60 meter per second j cap, which is given in the question, right? So first of all, I'm going to find R cross V. So what is R cross V? R cross V, which is equal to I j k, right? So I'm going to write the ijk for R as well as V. So what is, first of all, we will take the position vector R. So what is the I component of this R? Which is 3, right? 3 meter. And what is the j component of the R? Minus 4 meter. And there is no k component, so I have to put 0, right? Likewise for the velocity also, I component velocity, that means x component of the velocity is 30 meter per second. Likewise, our y component velocity is 60 meter per second. There is no k component, so that means z value is not there, so I have to put 0. As we already studied, when you find the ijk value, when you just find the value of r cross v, all the times this I will have the positive value and the j will have the negative value and the k will have the positive value, right? So first of all, what I am going to do, I am going to find the value of this I component. So how to find? I should not touch the first row and the first column. So I have the positive value. So when you just go this direction, you have to see here, this one, you have to go to the left hand side, which has the positive multiplication, and this side has the negative multiplication. So that means anything minus 4 multiplied by 0 is minus 0. And likewise, minus of, because when you go from this side to that side, it has a negative. So 60 multiplied by 0 is 0. So the I component will 0. Clear? So likewise, we have to do the same for j cap. So better I can erase this line. So now if you want to find the answer for this, what you have to do? We have to consider the j, right? So what I'm going to do, I'm not going to touch this middle part as well as the first row. So I am going to multiply this in the positive multiplication part. This one will be the negative multiplication part, right? So the j value has the negative, so minus j cap. This side is a positive multiplication, right? So 3 multiplied by 0, anything multiplied by 0 is 0. And this side, when you go, it is negative. So, but anyhow, if you multiply 30 with 0, again you will get 0. So your j component is also 0, right? And likewise, we have to go for the k component. K has the positive value, right? And I have to delete this for showing how to multiply. Clear? Okay, now I'm not going to touch the first one and the last one. Okay, so if you want to calculate the value of k component, that means k cap, what I have to do? I have to multiply 3 with 60 and then 30 with minus 4. So when you go from left hand side to this upward direction, it is a positive. From this side, it is a negative. So what you'll get? 60 multiplied by 3. What is the answer? 180, right? Minus, because when you go from this side to this side, it's a negative, right? So minus 30 multiplied by minus 4, which is exactly 120. Already you have one more minus. So minus with minus will have positive. So positive value of 120. Clear? So anything multiplied by 0, so this term will gone. Likewise, this term will also discarded, am I right, because of 0, and only you will get the k component. But 180 plus 120, what's the value? It's exactly 300, right? So r vector multiplied by v vector, so that means r cross v, we got exactly 300 k cap, right? We got the value of 300 k cap. Now what I'm going to do, because we are going to calculate the value of this angular momentum, so I have to multiply with mass, right? Because we have the rule. What is the rule? L vector, which is equal to mass multiplied by r cross v. This is r, okay? So r cross v already we found as 300 k cap, but the mass is 3 kilogram. So 3 multiplied by 300 k cap, I will give you the answer 900, but the unit is very important. What is the unit for the mass? The unit for the mass is kilogram, right? And then we have the unit for this r is meter, and this speed has meter per second. So kilogram meter square over second square, and the most important thing, it's k cap. Clear? So this is the answer for the first question, right? Likewise, we have the second subdivision also. So better we can read what is given in the second part. And in the second part, again, you are going to find the angular momentum related to the point -2 meter. That means it will come to the third part, third quadrant. Am I right? So better I can make a line here. Right? So what is this value? This value is, let's we take this is a maybe R1. Okay, so what is this position? The position they mention as -2. So that means it will come here. So -2. If you write in the vector form, this is nothing but -2 I cap -2 j cap. The unit is meter. Clear? So this is the, but the most important thing, we have to find what should be the delta. Am I right? Because we are just finding the relative to the origin. We already found this, but related to this point, we have to consider the first vector, first position vector also. So what we have to do, we have to find what should be the delta r. Clear? What should be the delta r? So better I will draw the line again. If you draw the line here, clear? And this value is delta r, right? And for this delta r only, we have to find what should be the angular momentum. Because whenever you have the coordinates, first of all, we have to identify where is this point exactly located in the graph, and then only we can easily find. Clear? So what is our delta r here? Here the delta r, if you just go to the second part of this, so better I will write here. The second part, r value here is 3 meter I cap minus 4 meter j cap. Clear? And what is our r1? Our r1, which is -2 meter I cap minus 2 meter j cap, and your delta r is nothing but r minus r1. Clear? So for that, we have to subtract this equation, the first one with the second one. So we have to deal with only I with I and j with j, what we did in chapter number 3. So 3 minus of -2, what is the value? Which is 5 meter I cap, and likewise here -4 minus of -2. So that means here you have minus, here positive term, because minus of -2 becomes +2. So by that, what you will get? -2 meter j cap. Clear? So this is the value of r, delta r, or we can just take this as r prime. Clear? For our easiest recognition, because so I'm going to take this delta r is nothing but r prime. Now for this, we have to identify again the angular momentum. So what is our angular momentum? So this is our position vector, right? After we find the delta r, this is our position vector, and for the same velocity, we have to find what is our velocity. 30 meter per second I cap, 60 meter per second j cap, right? So now for this, again we have to play with ijk method. So we know the rule, L vector, which is equal to mass multiplied by r cross v. Clear? So first of all, what I'm going to do, I'm going to deal with r cross v. So r vector which is equal to, sorry, r cross v vector, which is equal to I j k. As I mentioned earlier, this I have the positive, j have negative, and k have positive. So I have to make ijk method, and the I component of r vector, r prime vector, actually I have to write here as r prime, right? So what is the r prime? I cap 5 meter, right? And what is our j cap value for the r, which is -2. There is no k cap, so I have to put 0. Likewise, the same velocity, 30 meter per second for I cap and 60 meter per second for J cap. There is no K cap, so I have to put 0. Again, I have to play with this. We have to find the I cap, right? So I cap. So how to find I cap? You should not touch the first row and the first column, and we have to go this direction. So when you multiply 0 with -2, it's 0, and minus, when you just come this side, it is negative. So from here to here, it's positive, but from here to here, it is negative. Clear? So -2 multiplied by 0 is 0. Minus of 60 multiplied by 0 is 0. Clear? And the J cap has negative value, so I have to put negative in front of J cap, and I should not touch the first one and the middle one. So again, 0 multiplied by 5 is 0, minus of 30 multiplied by 0 is 0. So again, you will get 0, right? And now K cap we have to find. K have the positive value. 60 multiplied by 5, 300, right? So 300, right? And this direction minus, am I right? Minus of 30 multiplied by -2, it's -60. And already one more minus here. So -60 multiplied by minus, it becomes +60, right? So this term will discard it because of 0. So I have to discard this I cap and J cap, and only we have the K cap value. So therefore R prime cross V vector, which is equal to 300 plus 60, which is nothing but 360. And what's the unit here? Meter square over second square, K cap, right? Now what I'm going to do, I'm going to multiply with mass, am I right? Because the angular momentum formula is m multiplied by r prime cross v, correct? So r prime vector cross product with v vector. So the mass they mentioned in the question is 3 kilogram, and we already found the value of this r prime cross v is 360. So I have to multiply. So if you multiply, what you will get? We will get the answer. What's the value? The value 3 multiplied by 360, which is exactly, I think, 1080, right? So 1080, and what's the unit? Kilogram meter square over second square, K cap. Clear? So this is the answer for the second part. So better I will write it here. So this is our, I already mentioned here. Clear? So this is the answer for the second part. So while you answer, please read the question carefully and please do the calculation properly one by one, because if you made mistake in any one of the steps, then the final answer will be wrong. Clear? That's it.